Hello and welcome to our NetBeez webinar. We are going to get started. Just as a few ground rules, if you have any questions during the webinar, please feel free to type them into the chat or use the Q&A function at the bottom of the Zoom, and we will answer all questions at the end of the webinar after our live demo. So thank you for joining us today for the NetBeez unveiling of path analysis, which is our newest feature. Today, our speakers will be Greg Ness from our marketing department and Panos Vouzis, who is our co-founder and COO. So take it away, Greg.
Hey, thanks, Jess. We got a great program today. We're going to focus on helping you and your team accelerate the discovery of network and internet related issues. We'll talk about the remote work challenges. Then I'll pass over to Pano for traceroute and its limitations, how path analysis works. We have a really nice demo Q&A, and then we'll kind of wrap up talking about some of the business impacts. So let's talk about the remote work challenges, the eye of the storm. These are the conditions that are really driving the shift in network monitoring for new capabilities. And NetBeez focus, obviously, from the get-go on raw data and user experience has put them in a good position to look at the dynamic new levels of complexity we're seeing, from consumer-grade network equipment at the home to VDI, VPN, VoIP scaling, home Wi-Fi coverage and interferences. And I'm sure pretty much all of us have experienced some of these issues. And the net impact is increased help desk tickets, right? Escalating costs, escalating, challenges on the help desk, really around the difficulty in diagnosing these more complex, dynamic network, internet related problems. And NetBeez from the get-go, as I mentioned, they're focused on raw data, user experience, as they've developed both hardware, software, cloud, and then last fall developed and introduced the new remote worker agent, right? So we're looking into the eye of the storm with extension of visibility into these home network performance issues. Pano, maybe you can now take us through what we're going to be talking about.
Thank you, Greg. Hi, everyone. Yeah, so today we'll move on by talking a little bit more about NetBeez at a very high level, and then dive into the path analysis release that we are about to reveal in NetBeez 8.0. In a nutshell, NetBeez is a synthetic monitoring tool. It works by installing agents at every corner of your network. That can be hardware agents for WAN and Wi-Fi monitoring. Traditionally, we've been doing that for more than 5-6 years now. And then, of course, NetBeez agents can be installed as virtual in your VM infrastructure, Docker software packages on existing Linux boxes. And the purpose of the agents is to run this end-to-end testing, right? To capture user experience. We do this by a certain set of tests. We divide them in two groups. The real-time tests are pinged in SHTP traceroute and as of NetBeez 8.0 path analysis. And there's another set of tests that we call more about scheduled tests. They are more about network performance that you can run with iPerf, bandwidth and network speed and VoIP, obviously, right? And again, this test can be run between two NetBeez agents, between a NetBeez agent and another service, DNS server, HTTP application, a web app, etc. So now going a little bit, to the path analysis subject here. First, we'll talk about traceroute. So it's been around for almost 34 years. So I assume everybody in this that's attending right now know traceroutes since the beginning of their career in networking. And don't get me wrong, right? It's a great tool. That's why it's been around for 34 years now. And if you're on a WAN architecture, and of course, when it was released by Van Jacobson, that's all we knew about mostly, right? you know what to expect. You know your architecture pretty much. You might have some load balancing, etc. But you know, you go from A to B. You know the paths, the nodes, but always Traceroute helps you to visualize that. And it's what I call a one-dimensional path analysis. And gives you, of course, with every hop you go, and of course, just summarize here the way it works, that you increase, you send probing requests with increased ETL value, okay? And then intermediate routers, when they see that ETL is 0, they respond back with the time exceeded, and they send back the information, so you can get back the IP, you can do DNS reverse lookup, get latency, etc., right? But let's see how this falls short with a quick example. So let's take this small, I would say, as demonstration only route from A to B, from source to destination. And let's say now you're running a trace route, you want to discover what are the intermediate nodes on each hop from source to destination. So you send your first probe request, and you, of course, you hit the load balancer, and that's the only node on hop 1. So, okay, that's great. We discovered node 1. And now let's say when you're going for discover what's in hop 2, the load balancer routes the traffic to node A. So, okay, let's say now you have node A here, nothing wrong. And then the third time you're going for hop 3, load balancer sends the packet this way, right? So now what you're looking here for your route is this path, right? Which it's not only that is, you know, it's non-existent, but you also missed nodes B and C in hop 2 and 3. Okay. Of course, if you send more packets, chances are you're going to hit nodes B and C. But again, Traceroute falls short. I would say in the ultimate load balanced network, which is of course the internet, right? So if you're trying to visualize that, then Traceroute most likely won't cut it for you. And what solution for that? The first, I guess, well-known and widely adopted solution was proposed around 2006 by a research group in Sorbonne, and they named the tool Paris Traceroute. And the way it works is very simple. So to put it simply, of course, things get more complicated, but let's talk about flow-based load balancing, where a load balancer will send packets belonging to the same flow to the same interface. And the reason they do that is because packets arrive at destination in the same order. That's very important for applications like VoIP and video and others. But bottom line is that the way again to do this discovery, path analysis discovery, you send all these packets again. And if you send packets that belong to the same flow, you're going to discover the same route, right? If you manipulate now the flow, you're going to force or make load balancers route the traffic to different interfaces. And doing that multiple times, you can discover hopefully all nodes on every hop from A to B. And how do routers and load balancers decide what packets belong to what flow? Is by looking at this 5 tuple here: source IP, destination IP, protocol, source port, destination port. So if you change any of these, if you send, like, let's say 30 packets with this 5 tuple the same, you're going to follow the same flow. Let's say you change the destination port, then you send another 30 packets, you may discover a different flow and different route from A to B. And this is what's included in NetBeez 8.0. So this complements Traceroute. It's what I call 2-dimensional Traceroute, and it helps you discover these equal cost multipath topologies. In our case, we use a tool called Dublin Traceroute, which obviously was, you know, developed by somebody in Dublin, Ireland, and it's based on the same technique as Paris Traceroute, and has some additional information regarding NAT and MPLS labels. So for each hop now, we're giving information that has to do with what IP address each hop, obviously its node is, right? We'll do reverse DNS lookup, give you ASN, geolocation, routed time, of course, historical. Again, the idea behind NetBeez and the extreme value here is that we do this in a scalable way. You can always, everybody can do a traceroute from A to B on the command line, right? And see the results. But here's that we do that from all our agents, can be hundreds or thousands, to any destination. We store the results, we analyze them, we crank the data. You have historical to go back and review it, right? And all of this, of course, to give you more accurate representation of routing from A to B, and give you the ability to detect more easily and more quickly network performance degradation, and be able to correlate this with user experience behavior, and of course help you troubleshoot faster. So let's run a demo now and see what this looks like. All right. Okay. So I won't delve into the details about NetBeez, obviously, right? And this has been like topic of other webinars, and you can reach out for details. But here I have a demo dashboard that demonstrates path analysis for the purpose of today's webinar. And I have 3 agents only, 2 different kinds, wired and wireless. But again, the view, what we're going to be seeing here today, is uniform across all types of agents. Okay, wired, wireless, Windows, Mac, Docker, cloud, etc. And let's start by showing you how you create a new path analysis test. You just create a new target, right? Again, many people here are familiar with NetBeez, so let's start a test to GoDaddy. That's just the name of the target, and here we just put the URL. GoDaddy.com. Okay. Already the traditional pingness HTTP traceroute tests, and we're also adding path analysis now. Okay, so path analysis has certain options. Let's look in a little bit more detail what these options are. So here is how often the test runs. The default value is every 2 minutes, and the number of flows. So flows is what we talked about, right? So the trade-off here is that the more flows you use, better chance to discover all paths and nodes between A and B, but also have more accurate data in terms of delay and latency, because you have more data to average, right? Let's put it simply. More flows means more data. And with the advanced options, we have the source port number and destination port number. And this goes back to the 5 tuple we were talking about earlier. If you change these values, this is just the starting value, right? So for example, the path analysis test will start from destination port 33434 for flow 1. Then it's going to increase that value by 1, and that's going to be flow 2. So send packet with increased TTL value on flow 2, right? From 1 to 30 in this case. So 30 against the maximum. How many hops you're going to go down the road discovering nodes from A to B. And finally, interpacket delay, 10 milliseconds the default value. The trade-off here is, again, if you do a shorter interpacket delay, that means your test will finish faster, get your results back faster, but it's going to send, of course, more data in a shorter period of time. So you have a higher, let's say, burst of data, right, sent to your network. Most likely won't be a problem, but again, something you can fine tune if you want to. So we're leaving the default. Next. Now, select all. Imagine here you might have like hundreds of these agents or thousands on all your employees' Windows and Mac machines. So now you can just, with one click, start this test from all your employees to Google, Salesforce, etc. And then let's not worry about, again, alerting and other stuff, because this is more all about path analysis, right? So, okay, so the GoDaddy test has been created, but let's look, of course, at some existing historical data here, because it's going to take a few minutes for that specific test to get some data in. So let's look at this Pittsburgh agent. Again, this view is the same. And the way to see the path analysis test is through the agent's view with this new tab, okay, path analysis tab. And we see here this up top, the test going to Google every 2 minutes. And on top, we have here, we correlate the path analysis round trip time and delay with other tests on the same agent, the same target, like ping, HTTP, and also what alerts we have related over a period of time. And just to make it look a little bit bigger for you, let's maximize it. And so there it is, right? So this is what it looks like going from a NetBeez agent in Pittsburgh to Google. This is just for its hope of obviously is every node discovered, and how bold its line is represents how many flows go to a specific node. For example, this very thin line has just 2 out of the 20 flows, and this one has 8, and another 3, another 7, right? You can turn on labels. So if you want to look at each node and what's its IP address, right? Obviously. And then if you click or hover first over a node, you see IP address, name lookup, round trip time, okay, ASN, very important. And then clicking on it, you get more information like geolocation, statistics. And this, for example, for these 2 flows on a specific node is the 2 runs. So, and then the average is 18.138 milliseconds, right? This looks a little bit, you know, with 7 flows here, right? Right. So now this is what we call the aggregated view. So it summarizes kind of the flows, right? If we want to look now at each flow and what path it takes, we have the disaggregated view. And for example, I can click here on specific flow, right? I can turn it on, and then I can compare that if I want to with another flow. I can see the individual flows going from A to B, and the next step is to look at the ASN aggregated view. So if I click this now, this view is gonna group nodes together for its ASN, right? Obviously, this is my agent now. We have here Comcast, right? This Comcast agent having Comcast as the ISP. And obviously, Comcast is directly linked to Google, so we have only 2 ASNs here, right? So AS Comcast 7922 and AS 15161 for Google. And this doesn't look as interesting, so let's look a little bit more interesting test. So let's look at this. I was looking at earlier. Let's go from San Jose to Baidu. Okay, so let's look at this. There you go. All right, so this one now leaves an agent in San Jose, actually where I'm right now at home, and goes to China. So the first thing I want to show you is the ASN, right? So actually goes directly from here. Let me look at another one because there's another one. Here it is, right? So this one specific, right? So here I have AT&T at home. So of course the first ASN is AT&T, then goes to Telia in Sweden, and then goes to level 30 in China, and then reaches its destination, right? So these hops here don't really mean that some flows reach from my agent go to Sweden directly without going through AT&T first. But what happens is that some intermediate nodes here between my agent home and Sweden are not responsive. So there's direct line drawn, but can improve this a little bit, I think, by adding here a node that represents that. But The known ASNs are these 4 from A to B, okay? Now, the disaggregated view here looks actually, okay, the aggregated, all right, about its node. Let's maximize it, right? So again, so you see here in terms of performance, right? It's a little bit interesting here in terms of performance, what this shows. So I'm leaving, I'm AT&T here. I'm going node by node. I see 11 milliseconds, right? I'm still within AT&T, so on and so forth, still in the US, right? Then I'm in this order of results, like around, let's say, 30 milliseconds. Here I reached Hong Kong, but even here where I'm China Mobile, here is Telia. So Sweden is like 30 milliseconds, right? Then I reach Hong Kong is around 34 milliseconds, level 30. Then it hits again within level 30 from hop 11, the latency goes up to 200 milliseconds, okay? So by default, we mark nodes that have more than 100 milliseconds round trip time with orange and above 150 with red. So this is all red here. And actually, I can come here, and if I gonna, like in other case, right, I can say, hey, highlight all nodes that have more than 10 milliseconds delay, right? So you can see here with yellow, don't know how well it comes through, right? But you can see here all nodes that have more than 10 milliseconds. I can go to, let's say, 30 milliseconds. Here I'm around Telia, right? And then the rest of the nodes that are within level 30 again are in the order of, like 200 milliseconds. So I can mark them and see, hey, after my hop 11, everything is more than 200 milliseconds, right? Within level 13 in China Mobile moving forward. In specific case, at the end, we don't get a response from the destination itself. So we reach hop 30 without getting the response back, but that's a similar situation with traceroute, as you know. Okay. All right. And up top here, you see the latency in milliseconds for the ping test, simple ping test. And again, it's in the order of 200 milliseconds, because, again, that's the end-to-end, right? So from end to end with the simple ping test, I see that 200 milliseconds. I don't know anything about the in-between situation, but with the path analysis on the bottom here, I can go and really see what hop is, like the breaking point, and have a better understanding of where things are going, right? And similar with HTTP, this HTTP test to Baidu.com, and it's in the order of 4 seconds, right? So, and with that, I'm going to pass it back to Greg to wrap this up.
Yeah, so as you can tell from looking into this, the eye of the storm, right? The configuration of all these issues, that our enhanced visibility that is brought by 8.0 reduces the time and resources needed to diagnose network issues, boosts the productivity of both the network teams and the users, especially for the remote users. And if you're rolling out SD-WAN, obviously that visibility into the user experience can really help you accelerate adoption, and as you look at the various paths that those packets are crossing. So Pano, hey, thank you for a great demo. I think we're ready for a Q&A. It looks like we've got a few questions teed up.
Yeah,
Do you want me to read them, Pano, or do you want to read them?
I have time opening the Q&A Zoom. Can you please read them for me, please?
Sure. Okay, so the first question was, is this available for all NetBeez installations, or does it require a special license?
It's available to everyone. Existing customers are going to get upgraded automatically to 8.0 in a couple of weeks. And it's part of the whole tool set we are providing here.
Okay, next question is, what kind of resource load is placed on the agents? Is it more than before?
So it's going to be more, right? Because obviously every path analysis test adds, a certain number of packets to do its discovery. Again, we haven't seen like anything that can be, significant cause any problems. And you can always inspect how much traffic this is causing in real time by looking at the NetBeez agent, right? So here is like for the wireless interface, the real time kilo BPS is going to be the order of kilo BPS, right? And you can also see like the historical actually in terms of like how much traffic you put in your network, right? So again, I don't think it's something that you should be worried about, but if we want to be accurate, it does add more traffic, right?
All right, next question. Is path analysis using ICMP only?
No, you can use the UDP by default.
Cool. How do you deal with hosts that do not respond to ICMP? I guess similar question.
Yeah, I mean, this is this is something that it's a, I would say, native shortcoming of Traceroute also, that if the host doesn't respond, then we cannot discover it. There are techniques to do some discoveries, but for now, I would say that the same way on Traceroute that you don't get some responses back, it's going to look the same on NetBeez. I show you the Baidu example where after a specific node we reach the maximum of 30 and couldn't get to the destination with a reliable way. Yeah.
All right. Is path analysis already included with our current license and software licensing?
Yes, it is. As soon as it goes out and you see a notification about a new upgrade pending, just do it as soon as possible so you can get it as fast as possible.
Okay. Also, for everyone posting in the chat, it's okay. I can read them from there. If you posted your questions, you don't have to rewrite them in the Q&A. I can just read them from there. Okay, next is, what is done to provide clarity and accuracy on geolocation? Who is that right? Sorry, I'm unfamiliar with some of these terms. I'm in marketing.
Yeah.
Well, can you read that question? Will return registered owner of that IP from RIPE or ARIN? This is not going to reiterate this question. Very technical.
Right. So we use public databases to do the lookup of the geolocation, right? So we rely on those databases. Yeah, I mean, in most cases, you can provide you the information, right, of where about the geolocation. Sometimes, honestly, the database are not, they haven't been updated yet. Of course, geolocation is something that changes, obviously, right? And you might see some gaps, like I was looking at it yesterday earlier, that, but the answer is that we use public databases that to the vast majority of cases provided geolocation information.
Okay. Will this work with the remote agents?
Yes, it's going to work with all agents, including the remote worker agents, Mac and Windows. Yeah.
Do agents need to be deployed on the systems of every work from home employee?
The system, I guess, they refer to the device of the employee, and the answer is yes. I mean, you need to install our software agent, as we call. I mean, it's a software package, right, on the actual user's Windows or Mac machine, and that's going to give you that information you see here.
Are there any plans to add BGP monitoring?
Definitely, right? Something we have in mind, but TBD about timeline and everything else. So I cannot really commit to anything, but yes, we're putting it down as a feature request. Yeah.
And then a few questions from the chat. In terms of pricing, you can reach out to us via chat on netbeez.net on our homepage. There's a chat button at the bottom. Pricing depends on what you're looking for, how many deployments, etc. So you'll need to talk to our sales team about that. And then another question is, do agents need to be deployed? Oh, I already answered that. Sorry, that's a double question. Is there a trial version available for path analysis?
Yes, please reach out. You can run a trial email sales@netbeez.net. I don't know if you have that kind of information, but yeah, email sales@netbeez.net. You can reach out by chat, sign up on our website, netbeez.net, and definitely, yes, you can run a trial of this new feature and of course the whole dashboard.
Okay, two more it looks like. Can you set an agent IP as a target or destination for path analysis?
Yes, you can, as long as there's routing between, a target can be any IP, including an agent. Of course, if it's an agent itself has a special treatment because we know it belongs to the same dashboard, right, and everything. But the simple answer is yes, you can do it as long as there's routing between agents A and B.
Cool. How well does this handle anonymized routing?
Yeah, I mean, I guess this goes back to the previous question where some nodes don't respond to with an ICMP time exceeded, and in that case, we just mark the node as as an asterisk again, right? That we don't really have any response from that, and not the same shortcoming that Traceroute also has, but as like in a more of course the path discovery has to do with flows, not in like a one-dimensional way that Traceroute does it.
Does it provide insights into Azure AWS Cloud Fabric?
Well, that also depends on what Azure and every other cloud provider make I guess visible, right? The principles you apply are the same. We do the flow and we do the discovery. We don't have any specifics about Azure. We treat it as any other host and routing. So we could look at specific examples and see what's there. If somebody's interested, you can do a quick test and see what would tell there.
All right, I think that we answered all of the questions. Also, if you have any further questions, we would again be happy to answer them via chat on our site, or you can email us at info@netbeez.net. And also, it looks like